Hello everyone, my name is Jingsong Lee. Today I want to share something about Paimon, or also AKA Paimon. Okay, I worked in Flink community, and now I'm focused on lake format Apache Paimon. So at first I want to ask you 3 questions from big data workers. I asked many companies workers. They told me there are 3 main questions. So the first question is, we have launched, we have started many real-time applications. We are using Flink and Kafka and Flink system and KV system and OLAP system. But current days, the cost is becoming more and more important. So actually, we want low latency, and then we also want to low cost too. So we want both low latency and low cost. This is the first challenge. So the second challenge is now there are many big data frameworks, many storages in big data system. So if there are many data in many systems, so if you want to do something special, or you have many batch data, you want to do some streaming to do some real time, you must move data from batch system to Flink or to Kafka or to OLAP system. So there are lots of frequent data movement, and actually you are very difficult to develop the data. So, and the complex architecture, it is hard to maintain so many systems. So this is the second questions. And the third question is data for AI. We already talk about it. AI is very hot, and AI also has its AI infrastructure. Actually, for our big data system, we also want to be the infrastructure for AI. So how big data and AI have some relationship, and we can do some combination. So these 3 questions. So I want to talk in China now. Yeah, today Jakarta is very hot, and actually in China it is winter now. It's very cold. In China, in big data system, we already have very many companies. They are using Paimon to build a unified data lake storage. We know in the whole world, actually in big data system, the lake format is very hot. And in China, Paimon is very hot. So how to use Paimon? So for the first question, you want low latency, you want a low cost. How to do it? You can use Flink and Paimon to build a Streaming Lakehouse. And you can, because you are not using Kafka, the queue system, the Kafka has a server, Kafka has its SSD storage. And you may use some OLAP system, KV system, they are all online system. Or it is very fast. They are very fast. They have very low latency, about seconds latency or milliseconds latency. But the question is that you really want milliseconds? Actually, for the real business, actually milliseconds are most of your case. You just need milliseconds latency. So you can use Flink and Paimon. Paimon, it is a lake format. It's based on the file system, something like you can use HDFS, you can use OSS object store, you can use S3. So Paimon is cheap, and you can use Flink and Paimon to streaming read, and to achieve low cost of offline batch data accelerate. So this is the first question. So the second question is, actually Paimon today provide many features to support batch processing, to support streaming processing, and to support OLAP processing. So Actually, in our company, you can just have one unified storage system that you can use Paimon to build a unified storage for streaming, just like Flink for batch. You can just use Spark, and for OLAP, you can use Starlocks. So you can build one unified architecture, and in this way, you don't need to use other system. You can do all computation on one storage system. So this is for second question. For third question, data lake and AI actually has done many features to make AI happier. Something like Paimon also provide Python API. You know about it. In AI world, Python is really important to AI. So Paimon provide Python API to allow Python SDK to read data from Paimon to write data into Paimon. And then Paimon also provide interesting feature, element object table. Object table is something you can just mapping a location on OSS or S3 to a Paimon table. And then you can just read this Paimon table. You can read all unstructured data. So it is very interesting. It really bring unstructured data into the lake format. So what is Paimon? So I bring these three graphs. So first I want to introduce Hive. So what is Hive? I think Hive is a shared file storage for batch processing. You know, Hive just a directory. There is a directory in it. There are many org files or Parquet files. It is very simple architecture, and it just provides the basic functionality. If you are using Hive, you know about in batch processing, you can only use insert overwrite to overwrite a partition. Of course, you can use insert into, but insert into has many problems, just like data missing or data duplicated. Yeah, it will cause many problems about the data consistency. So only way to use Hive storage, I recommend you just use insert overwrite. So we know Iceberg Hive storage is not so good. So Iceberg comes. Iceberg, I think, is a shared database storage for batch processing. Based on the top of the Hive, Iceberg provides more features, just like ACID, transaction. In Hive, you can only use insert override, but for Iceberg, you can delete, you can update, insert some record. So there is guarantee about data consistency. You don't need to care about there will some data loss. And then Iceberg provides something like data skipping. Iceberg controls every file, controls the metadata, record the metadata of every file. So it can do some data skipping based on min-max of the columns. And then Iceberg managed the snapshots of the table. So it can do, you can do some time travel query on Iceberg table. So this is Iceberg. I worked in Iceberg community 2020, and we in Alibaba we contributed Flink Sync into Iceberg community, and we also contributed Flink SQL integration in Iceberg community. But then we found that Iceberg is not very good to streaming processing. Why? Because Iceberg is designed for slow changing data. So for streaming, it is not, the initial design is not for streaming. So we developed the Paimon. So Paimon is a lake format for streaming, or you can say for Flink streaming processing. So Paimon is a shared database storage for not only batch processing, but also for streaming processing. We combined the lake format and the LSM log structure merge tree. LSM is the best structure to update. And we integrate Flink to streaming write, streaming read, automatically compaction. You don't need care about small files. It is very useful. And we also introduced the deletion vector feature on the top of lake format. So OLAP query, Spark query, or OLAP query can query the update table very fast. So let me just explain what's the difference between iceberg and Paimon. So, what is iceberg? So iceberg is iceberg in the lake. You can imagine an iceberg in the lake. On the top of a lake, the iceberg should not be so big. And under the water or inside the lake, the iceberg is very big. And you can imagine how can you make iceberg very fast? You can imagine something iceberg can move very fast on the data lake. Can you imagine that? I think it's very hard, unless you must have a very super power engine to push the iceberg. But the Paimon, the logo of Paimon is a sailfish. So, sailfish. What is sailfish? Sailfish is the fattest fish in the lake, in the sea. So I think for the initial design, Paimon is designed for streaming, and Paimon is fast. So I've talked about it. Paimon, many companies in China, in Chinese community, has used Paimon into their production environment. So I think Paimon is most popular lake format in Chinese community. I've seen many companies, more than 10,000 Flink jobs, and Flink and Paimon to build a streaming pipeline to improve business timeliness. And I know in this year, newly enterprise adopted more than 100 enterprise has been adopted by numerous enterprises. And in this year, Paimon also continues in innovation into 2024, and many new innovative features comes in Paimon community. And we have more than 200 contributors. They come from Alibaba, House, TikTok, Vivo, Shopee, and Xiaomi, and more companies. So this is the development history of Apache Paimon. So Paimon initialized in Apache Flink. It is Flink table store. It is a sub-project of Flink. And its original is Flink table store. It's the original design for Flink streaming on the top of lake format. Yeah, and then we found that lake format, what is the best feature of the lake format? It is open. It shouldn't, so Paimon Flink table store should not just be a sub-project of Flink, because the open, we should open the Flink table store to more engines, just like Spark, just like Starrocks, just like Hive and Trello. So Flink community contributed the Apache Flink table store to Apache incubator. And Paimon comes and becomes Apache incubator project, and open to other rather than Flink, Spark, Trello, and others. And this year's, Paimon just become Apache top level project, and graduated from Apache software. And we have a very integration with Flink, Spark, Presto, Trello, and more computer engines. And in this month, we want to release Paimon 1.0, and it is coming. And it should be a unified lake format, and unified for streaming, for batch, for OLAP. And we have introduced a lot of features, just like view support, list catalog, and iceberg snapshot. So this is progressing in Alibaba. Yeah, Flink and Paimon in Alibaba this years have very great progress, and I'm very excited to introduce this. We have moved two big table from old warehouse to Paimon lake storage. One table is page view. You know, every application in Alibaba will produce the page view, and all page view will be collected to one table. That means page view table. And another table is orders. Yeah, every will produce orders. So these two people, or most of electric business are based on these two people, these two tables. So I'm very excited to move these two people and related business into lake format to Streaming Lakehouse. So the storage of Paimon almost 100 bytes, and the max record per second for that page view table are more than 40 million per second. So the old architecture, something like Flink and Kafka, and combines stateful streaming. So its character is seconds latency and real-time ETL. And the disadvantage is that the streaming and batch separated. It means you must write a streaming cycle, streaming pipeline, and then you must write a batch pipeline. And two works are very complex. And then Kafka cannot query it, because Kafka is something in a queue. It cannot be queried. So the Billy's ETL, the Billy's OLAP cannot query the real-time data. And third is it is hard to reuse middle data, because Kafka is something like queue. You cannot reuse the queue very easily. So this architecture has moved into Flink and Paimon to build the Streaming Lakehouse. So the character of Streaming Lakehouse is it is minute latency. It means some business you don't need 2 seconds latency or milliseconds latency. You can accept minute latency, and into Streaming Lakehouse architecture, all tables can be queried in real time. And the streaming and the batch can be unified, because for the same storage, same computation engine, Flink. So the Flink cycle can do streaming cycle, Flink cycle can do batch cycle too. The cycle have been unified, the storage have been unified. So the advantage is that the unified storage and all tables are open and can be queried. And actually, you can also use Paimon to do some duplicate. ODS, DWD, the initial tables in the data lakehouse can be deduplicated in real time. So after we did the migration, Flink and Paimon in Alibaba, this is the benefits. So benefits is batch processing. The first table has been changed into streaming from batch. So the latency, so we achieved 1 hour ahead of schedule. Latency had been reduced. And the development and operation efficiency can be improved in over 50%. And all tables can be real-time OLAP analysis for business BI. And we also introduce real-time data deduplication, and this can greatly reduce the cost. So the last one is Paimon use DFS, something like object table store, object store, something like S3, VS, Kafka, SSD. It can greatly reduce cost. So next, I want to introduce the ecosystem of Paimon. So for the SQL query, you can use Flink and Streaming SQL or Batch SQL. You can use Spark SQL. You can use Hive, Starks, Doris, Tradle, and something like these open source computation systems to do SQL query, SQL write, and SQL maintain. And you also, Paimon community also introduced the CDC ingestion. It is very easy to CDC ingestion from Kafka to Paimon with schema evolution. That is very convenient. And also MongoDB, also MySQL, Pausa, and PostgreSQL. And then in 1.0, we also introduced Python API on top of for Paimon. So through Python API, we can unlock many Python ecosystem, just like Arrow, PyTorch, Ray, Pandas, and more. So the ecosystem is not enough. It is enough in China if you are using Alibaba Cloud. So you will find that everything is good. But if you are using AWS or some external, some enterprise computation engines, just like Snowflake, Athena, and BigQuery, you will find that these computation engines cannot support Paimon. So what we should do? What we should do is we introduced Iceberg snapshots in Paimon community. So through an option, you can enable Iceberg snapshot to let Paimon to produce Iceberg snapshots for our tables. So through this, we can let Iceberg computer agents on computation engines to query data from Paimon, just like you can use Snowflake, Athena, Impala, BigQuery, Presto, and Dremel, and all Iceberg ecosystems, including Python API, including Rust API. So next, I want to share about some Python API of Paimon. So we called it Paimon. We actually at the beginning of development of Paimon, we have two options. The first option is we can re-implement or in Python as Python language, but Paimon is very complex. It has primary key support. It can merge engine. It has LSM, long structure merge tree. So another way is using Py4j. So Py4j is a very good lib you can run JVM in Python. So another lib is Arrow. So Arrow is a very, very good lib you can exchange data between two languages. You can produce data in Java and pass the data into Python. And you can generate the data in Python and pass data to Java. So through these two technologies, we have introduced Paimon, this Python SDK of Paimon. And it has full features of Paimon. It has catalog API. You can use it to read data from Paimon. You can use projection. You can filter, push down, and you can write data into Paimon too. So this is an example of using Paimon. So it's an ecosystem through Python API. You can unlock all Python ecosystem, including PyArrow, including Pandas, including DuckDB, and Ray. So here is an example to use Paimon. You can declare a catalog and get a table and use a new read builder with a projection and scan data and read data into Pandas and analysis data from using DuckDB. So finally, I want to introduce object table. I've talked about the object table. So object table means that we can manage unstructured data in the structured way. Yeah. If you have many unstructured data in OSS bucket or S3 bucket, Yeah, you have some JPG picture, you have some movie, you have some text, you have some MP4. And you can use Paimon object table to mapping the metadata and through refresh into a Paimon object table. You can see the Paimon object table is a structured view, and it has many columns, including path, name, and modify time, access time, and MD5. So through this table, you can use something like a PySpark or Flink Cycle or Spark Cycle to analyze the unstructured data. So here is the example to PySpark filter images and convert the unstructured data to PDF. So you can use a Spark session, PySpark, and you can get the object table, and you can do some filter, and finally you can convert one by one to PDF. So here is the example. So thanks everyone to listen from me. So I recommend you to just try about the payment. You can click this website to payment website, and you can download the payment lib and try it. Welcome to just chat me to let me help you. Thank you.
Thank you so much, Mr. Jingsong Lee, for the presentation on Paimon 1.0.